Bismillahirrahmanirrahim. Welcome to MIT. Today we are going to solve some trigonometric problem from the past papers. First question belongs to paper 060613 May June 2024, and the question belongs to question number 12 actually. And the paper you can see over here also, it's written 0606 S24 question paper 13. So let's move on to question number 12. Question number 12 says sec 3 theta minus pi over 2 equal to 2 for for neg- negative pi over 2 until positive pi over 2. Remember, whenever any graph is given, not original graph given, some cases transformed curves or graphs are given, then first of all we will have to find the required domain. Okay, the given domain may not be so convenient for us to be applied. So here look at this, it's actually three, it's not sec is opposite to cos, inverse of cos. So here the theta is given, we will convert this sec into cos. So cos, actually we know the graph of cos theta, isn't it? But here look at this, the graph is not so simple as it is cos 3 theta minus pi over 2. That means this is a transformed graph. How was it transformed? First it was enlarged by the scale factor 3, then it was translated to the right direction by pi over 2. So ultimately what I am trying to make you understand is that this is not simple cos graph, this is transformed cross cos graph. So in this case, first of all we will have to know the domain. Let us find the domain. The given domain is given, let me erase this first. Well, the domain says negative pi over 2 less than or equal to theta, then less than or equal to pi over 2. Now we will convert it into the given angle. First it is enlarged by 3, so we will write 3 pi over 2, and this is going to be 3 theta. That means we are multiplying all sides by 3, so it is going to be 3 pi over 2. After that, and again there is translation by negative pi over 2. So we will just add up that negative pi over 2, negative pi over 2. 3 theta minus pi over 2 equal to or equal symbol 3 pi over 2 minus pi over 2. If we simplify this, then what is it going to be? If we simplify, the left side is going to be 3 pi minus 1 by, that means 4 pi, negative 4 pi over 2. Then 3 theta minus pi over 2. Let me erase this part. Minus pi over 2, and in the right side what is it going to be? From 3 pi, if we subtract 1 pi, it is going to be 2 pi over 2. So ultimately we are going to get, if we divide 4 by 2, it is negative 2 pi less than or equal to 3 theta minus pi over 2, then pi. That means our new domain is negative 2 pi until positive pi. And as it is given in radian mode, we can convert it into degree. 2 pi means 360. So negative 360 degree until pi over 2 positive, pi means 180 degree. Well, if we convert it into degree, it becomes easier and convenient to identify the quadrants. That's why I have written in degree, but it is not essential. You can complete up to this. Okay. So what have we got? The domain of this graph is actually, this function is negative 360 until 180. So let's start the main solution. So remember, whenever any transformed graph is given or function is given, then you'll define the domain first. If you fail to find domain first, then later on you will remain confused what can be your possible values of y, corresponding values of y or the function. That's why first of all we will define the domain. Now let's go to the question. The question says sec 3 theta minus pi over 2. Let me copy this question on the next page. Sec sec 3 theta minus pi over 2. 3 theta minus pi over 2 equal to 2. So sec is inverse of cos. So we can write 1 over cos thrice theta minus pi over 2 equal to 2. That is, if we do cross multiplication, we will get 3 theta minus pi over 2 equal to 2. Sorry, half. It is going, if we reverse, it will be half. And we are going to transpose cos to the other side. 3 theta minus pi over 2 is equal to cos inverse of half. Well, and as our angle is positive, so cos positive is thrice theta minus pi over 2 equal to cos half. Cos inverse of half is actually pi over 3. Now let's see, according to our domain was what? Let's go back to our domain. Our domain was, look at this, from 360, negative 360, that means in anti-clockwise direction as well as clockwise direction. Let's see, where do the angle fall in. First of all, the angle will fall, look at this, this is our quadrant, and as this is positive, for positive of cos, the angle will fall either in the first quadrant or in the fourth quadrant. Okay, either first or fourth quadrant. Now let's see, in the first quadrant we have already got the basic angle. Basic angle is how much? Pi over 3. So this one is pi over 3. Pi over 3. Now, as we do have the domain in the negative direction as well as positive direction, we will have to define in both ways. Okay. Well, now in anti-clockwise direction, first angle we have already obtained, it's pi over 3. What about the fourth quadrant? Anti-clockwise, if we talk about this one, our we should not forget that it will be, our domain was what? Our domain was from negative 360 to positive 180. So positive 180 is actually this quadrant. This quadrant is positive 180 or less than this. As angle doesn't fall here, so we don't have any other measurement. We can only choose the first quadrant. Okay, so if we choose first quadrant, our angle is going to be, look, in the fourth quadrant we cannot get, because fourth quadrant means it will be less than 3, more than 270, means here it is 360 or less. No way we can go to 360, because our domain was what? Our, for positive angle, our domain was 180 degree. So let me write the domain again. Our domain is negative negative 362, negative 360 until positive 180. Okay, positive 180. So let me draw the figure over here again. So our angle is over here, or for positive it may fall over here. This way. Okay, angle is over here, or angle may be over here. Now anti-clockwise direction for positive value is, so our range is from 362, negative 362, positive 180. Let me erase this portion so that it becomes easier to understand. So our range is what? Our range is from negative 360 until, suppose this is theta, not theta, let me suppose it to be x positive 180. So no way we can forget our domain is the key role player in this case. So in negative positive direction it may be maximum 180. So in the fourth quadrant it can never be 180, it must be more than 180. So anti-clockwise direction we have already finished, there is no more for positive value. Now let's talk about, as the domain is given for negative value means you will have to move clockwise direction, this way. So let's calculate in clockwise direction. So for clockwise direction, first this one is negative pi over 3. Remember, for clockwise direction it must be negative, the angle will be negative. If you move anti-clockwise then it's positive. If you move clockwise then it is going to be negative. So in clockwise if you move like this then it will be negative. Okay, so we are talking about the negative value. So for the first quadrant, I mean this fourth quadrant, it's negative pi over 3. What will happen in this case if it is in the first quadrant? So in the clockwise direction it will be less than 360, and you know our domain is in clockwise direction, it may be 360 or more than 360. So we can choose this one also, this is acceptable. Okay, so it is going to be 360, that means this portion. Okay, let me erase this one again. If we erase this figure, let's see in clockwise direction how much can we get. Well, so this is the quadrant, angle is over here as well as over there. Okay, so if angle falls over here then what will be the value? The value will be actually this one. Okay, how can we calculate this? It is going to be 360. 360 means 2 pi, negative 2 pi, because we should not forget that we are moving clockwise direction. So 2 pi minus this angle, this angle was how much? Pi over 3. So these are the values we have got so long, total 3 values. There is no more value applicable in this case. So one is, look at this, if we move clockwise direction, if we move this way means anti-clockwise direction, then that is applicable for positive values. If you move clockwise direction like this way, this way, not the starting from fourth quadrant, if we move from here then that is for negative value, negative domain. So we have chosen that, we have verified both the positive direction this way as well as this way. That means there is no more value left to be obtained. So these three are the values for the given domain. Now we will identify. They told us to not to find the domain, they told us to find the value of theta. Let's move on to the next page. So it is 3 theta, 3 theta minus pi over 2. We have got the first value was pi over 3, pi over 3. Second one was pi over negative pi over 3, negative pi over 3. And the third value we have got is negative 2 pi plus pi over 3. Let's go back whether we have written plus or not. It will be actually not negative, it will be plus, because as we are moving clockwise direction, this portion should be subtracted. Look, always the angle, basic angle, should be added or subtracted. As we are moving anti-clockwise direction, the angle is negative, so from negative if we want to subtract, it must be positive. Means it will be like this, the angle is over here. Okay, angle is over here. Now for this one we require total is 360. Okay, from 360 the we require this angle, we require not whole of this, our angle is actually this one, this one is our angle. Okay, this is our angle. So this one will be from 360. If we subtract this portion, this portion is, you know, the measurement of this one is pi over 3. So from 360 if we subtract this pi over 3, we will get our desired value. Now as we want to subtract, there should be 360 is negative for being clockwise direction. From 360 we will just subtract this one, that means symbol will be positive. Well, now from left side if we simplify this pi over 3, this pi over 2 can be taken to the right side, and it will be positive pi over 2 comma negative pi over 3 plus positive pi over 2. The third one is here if we calculate it from 6, 3 twos are actually 6, from 6 pi if we subtract 1 pi, it is negative 5 pi over 3, and from the left side there is pi over 2 to be added. Then 3 theta is going to be 3 theta. If we simplify here, then 2 pi and 3 pi, it will be 5 pi actually. 5 pi after simplification, and it is going to be negative 2 pi, positive 3 pi. So it will be pi over 6. Then the next one is going to be from 10, if we subtract 3, it is going to be 7 actually. Negative 7 pi. Well, after that, if we transpose this 3 to the right side, what is it going to be? It will be 5 pi over 18 and pi over 18. After that, the third one is negative 7 pi over 18. So that is our, as this is the last step, we can leave them at this stage or we can arrange in order. First negative value should be written, theta is equal to negative 7 pi over negative 7 pi over 18. Then the smaller is pi over 18, pi over 18, pi over 18. Then the greatest value is 5 pi over 18. That's all about the solutions. That means, so what are the key points here? First of all, we will have to find the domain. For when, if the sinusoidal graph, I mean sine theta or cos theta is not given, sine theta or cos theta. If it is not given directly, that means this is a transformed graph. In case of transformation, first of all we will multiply by the scale factor. It was 3 times of theta, that's why we have multiplied all the sides by 3. Then there was translation of pi over 2, then we have added by pi over 2, I mean negative pi over 2. Then we got actually our domain here for the given root is from negative 2 pi until pi, and for our convenience we can convert them into negative 360 to 180, means in degree. So that is how, if you can define the domain first, then your solution becomes easier. Otherwise you will have to go a long way for trial and error method. Thank you all for this. Let's move on to the next question. Well, I think you all have understood the fact of the previous solution. Yet, for better understanding, we can practice one more solution from paper 970911, and the question number not 6. Let me see the question number. Question number is going to be 5. Question number, it will be 5. Question number 5. It is question number 5. So the paper, let me remind you of again, this is actually a question of A level 9709/11, question number 5. So from paper 11 we are going to solve question number 5. Let's see what question says. 5a says prove the identity sin square x minus cos x minus 1. Well, A says prove the identity sin square x minus cos x minus 1 over 1 plus cos x equal to negative cos x. So if we write this sin square, let me write the question first. That is sin square x minus cos x minus 1 over 1 plus cos x, 1 plus cos x. Then in the numerator we know that sin square x means 1 minus cos square x, 1 minus cos square x minus cos x minus 1 over 1 plus cos x. Well, then we can this one can cancel out the other one. So negative cos square x minus cos x, we can take a negative cos x as common. Then there remains only cos x plus 1. That means it's exactly as the denominator is, cos x. Well, now 1 plus cos x and cos x plus 1, they're exactly same. They can cancel out each other, equal to negative cos x. They told us to prove and we have proven so. So it's proved. That's all about the solution to A. Let's move on to question number B. B says, hence, solve the equation sin square x minus cos x minus 1 over 2 plus 2 cos x equal to 1 over 4. So let's write the question first. The question is sin square x minus cos x minus 1 over 2 plus, in the denominator we can take 2 as common. Okay, so this may be the second step. If we take 2 common, it is 1 plus cos x. 1 plus cos x is equal to 1 over 4. As we have taken 2 as common, this 2 can be transposed to the other side. If we do so, in the denominator there remains 1 plus cos x over sin square x minus cos x minus 1. On the right side, if 2 is written on the right side, it's going to be 2 over 4. Well, and from the previous question, we have already proven that this is equal to, let's move on to the upper part. Yes, it was actually negative cos x. So it is negative cos x on the left side, negative cos x, negative cos x, and the right side it is going to be half. If we simplify, the negative symbol will be transposed to the right side. So cos x is equal to negative half, and x is equal to cos inverse. Before moving on to this, let us see the domain. The domain is 0 degree to 360, and all of them are positive. Remember, in the previous solution, first of all we defined the domain. Here domain, we are not doing anything to the domain, because actually look, the angle in the domain given is x, and we are searching for also x. This is not a transformed curve or graph. The previous function was a transformed from function. That's why we have defined the domain, new domain. And as this one is the actually original function of cos, that's why we don't need to identify or define the domain. So domain is given as it is from 0 degree to 360 degree, and it is definitely in anti-clockwise direction, because the domain, all the values are positive. So it is going to be, if we don't need to define anything in the domain. So x is equal to cos inverse of cos inverse of negative half. So this is our function. Let me move on to the other page. X is equal to cos inverse of negative half. First of all, in the quadrant we will see where cos is negative in positive, in anti-clockwise direction, because our domain is positive. So cos is negative in either in the second quadrant or in the third quadrant. In the first and fourth quadrant, cos is positive, so angle will be either this one or this one. Well, so for this one, first of all, or x is equal to, actually our basic angle cos inverse of half is equal to cos 60 degree. So it is actually 60 degree. This one is 60 degree, either 60 degree, or this will be the our angle. So what will be it? If it is 60 degree, this is our angle. Okay, this is our angle actually. So how can we find this? It will be 1 from 180. 2 quadrant means 180 degree minus 60 degree. Well, one of the values. The other option we get, that is from the in the third quadrant. So 180 degree, and as it is 60 degree, this one is 60 degree. So it will, the angle is this one. Okay, so it will be 180 degree plus 60 degree. Hence, finally we are getting our root is 120 degree as well as 240 degree. There is no more value acceptable in the given domain, so we can take only these two values. That is the answer to this question. I think you have understood better than the previous one. So let's move on to one more solution, so that it makes you well. Let us solve one more problem. This question belongs to paper 060611, May June 2024 session. Well, so let's move on to, and the question number 8. We are going to solve question number 8. Let's move on to the question number 8. Question number 8 says, solve the equation 4 sine square twice alpha minus pi over 3 equal to 1 for this is our domain. domain is given negative pi over 2 until positive pi over 2. So we'll have to define the domain again, because this is not original sine graph. This is a transformed graph. First of all, we can start writing the solution. It's 4 sine square twice alpha minus pi over 3 equal to 1. We will define the domain later on. Let us solve some of the parts. So sine square twice alpha minus pi over 3. If we transpose this 4 to the other side, it's going to be 1 over 4. And as this is sine square, so we will simplify it as sine. So sine, if square is twice alpha, sorry, if square is transposed to the other side, it is going to be square root, and square root of 4 is 2, so it is going to be actually positive negative half. All of you know it, algebraic manipulation. Then our root is going to be twice alpha minus pi over 3 is equal to, if sine is transposed to the right side, it is going to be inverse. So sine inverse plus minus half. Well, now we will have to define our domain, because this is not simple. Look, this is not sine theta or sine alpha. Actually, this curve has been transformed twice. First, it has been enlarged with the factor scale factor 2, then it has been translated by pi over 3. So let us find the domain is given negative pi over, let me write in the negative another on another page, negative pi over 2 until alpha positive pi over 2, and our graph was enlarged by 2, so it will be negative 2, means we are multiplying every side by 2, twice alpha, and that is 2 pi over 2. Then the graph has been, let's go back to this, the graph has been, look here, translated by pi over, translated with the vector pi over 3. So pi over 3 should be added to pi over 2. 2 pi over 2 means, actually if we simplify, it is going to be only pi. So negative pi plus pi over, not plus, I think it's negative. So negative pi over 3. So twice alpha minus negative pi over 3 less than or equal to, it's pi minus pi over 3. So ultimately, what are we going to get? It is negative 3 pi and 1 pi. So negative 4 pi over 3 twice alpha minus pi over 3. Then it is 3 pi minus 1 pi, means 2 pi over 3. Well, then it is going to be, if we convert it into degree, look, this is not the part of your solution, it's actually for our own convenience. If we know the domain well, then ultimate solution we can find the solution precisely. Otherwise, we will have to apply a trial or error method. Some will be rejected later on, so that our bulk of words, to make our workings less, we can just simplify this. So this is not the part of your solution, this just we are doing this for our own convenience. So it is going to be 60, so negative 240 until twice alpha pi over 3, and this is also going to be 60, that is 120. So this is our ultimate domain. So we can use this domain negative 240 to 120. Let it be written. We will keep it visible in our beside our solution. So our solution was what? Not this one, this. Okay, so let us write on a new page. So it is about twice alpha equal to twice alpha minus pi over 3 equal to sine inverse of positive and negative half. Well, and for our convenience we can just show our domain. What was our domain? Domain was from negative 240, from negative 240 until it is positive 120. Okay, positive 120. This is just so that we can have a look at that. Well, now we will find that the domain is loop from negative direction. Negative direction means clockwise direction. So first of all, let's draw the quadrant. Okay, so as the for positive value, let's talk about positive value. The angle is actually over here, as well as the angle can be over here, from here to here. Okay, so for positive value, this positive direction means anti-clockwise direction. In this way, okay, we will calculate in this way, clockwise direction. Okay, anti-clockwise direction. So it is going to be anti-clockwise direction. First, sine inverse of half is actually pi over 6. All of us know. Then, or using the calculator also you can find sine inverse of half is positive. For positive is pi 6. So another one is for anti-clockwise. For positive value, it may be on the, because look at this, our positive domain is how much? 120. So 120 may be accepted in this quadrant, second quadrant. So for second quadrant it is going to be pi minus pi over 6, means from whole of this, if we subtract this portion, then will this portion is actually pi over 6, pi over 6. So if we subtract from whole of the whole means pi, from pi if we just subtract this portion, we will get the angle in the second quadrant. Okay, so positive direction we have completed. Now in negative direction. Okay, so in the negative direction, let me draw another one. In the negative direction we will go over here, our angle is here as well as there. Okay, let me erase this, draw one more. Okay, angle is over here. Now for negative direction it will move on to this. So negative angle is maximum 240, so angle may fall over here. Okay, and we have already decided for positive value of angle, angle may fall over the first quadrant or the second quadrant. Okay, let's find over here what will happen in this case. This, look at this, this is for negative domain, means we are moving clockwise direction. Clockwise direction is always negative. So here it is pi, if the angle is over here, if the angle is over, so pi plus this portion. Okay, pi is second quadrant, from here means third quadrant, from here up to here it is pi. Okay, then there is something more, so pi, that is to be added, minus pi over basic angle is 6. Okay, then can we move on to the first quadrant in clockwise direction this way up to this? No, because actually our negative value is up to maximum 240. So 240 can, in the this quadrant it cannot be 240. Up to this it's 270. So if we move on to this quadrant, first quadrant, it will be more than 270. So which is not necessary. So we have completed all of this for clockwise and anti-clockwise direction, forward positive value and negative value. Then another one negative value, another negative value, let me erase this. This was only for the positive value of sign. Now we are going to know about a negative value. What will happen in case of negative? Suppose a negative angle may be over here or there. So clockwise in anti-clockwise direction, if we move up to here, it will be more than 180. So our domain is 120, so we cannot take this. That means for positive value there is no more angle left in anti-clockwise direction. But what about clockwise direction? Clockwise direction is for a negative, this one, as well as this one, up to, sorry, angle will start from here to there. Okay, so it is this one is negative, negative pi over, we have already decided it's 6. So negative pi over 6, negative pi over 6. And another one is in this quadrant. If it is in this quadrant, so it is going to be negative pi over negative pi plus, that means we will have to subtract this pi over 6. Well, sorry, we made a little mistake in this one because there cannot be 5 roots here. Look at this, the first one is all right for positive value, and second one, yes, this one I think it's wrong. Let's check again. So for positive value, angle will be over here or angle will be over here. Okay, so here it is pi over 6 we have decided, and this one will be from 180. If we subtract, total is 180. From 180, if we subtract 180 minus 30, it is going to be 150. So positive 150 is not in our domain. Look, our domain is 120. So actually this is not accepted. It's more than, it's exceeding our domain. So this is not correct. Rest of the 4 are our value. Let's uh, solve the rest of the 4. Well, then this one is also not necessary for us. Well, so it says the next step, now we are going to transpose this one to the right side, 2a on the left side. So pi over 6 plus pi over 3. Then next one is going to be negative, look at this, negative 1 and negative 6 means negative 7 pi over 6. Then the third one is negative negative pi over 6 plus, oh sorry, here also we skipped something, let it be written. From the left side we are shifting this one, pi over 3. So our third one is negative pi over 6, negative pi over 6, which will be added to pi over 3 from left side. Well, and the fourth one is negative 6 positive 1 means negative 6 pi plus 1, so it will be negative 5 pi, negative 5 pi over 6, and from the left side we are bringing pi over 3, pi over 3. So what is it going to be? Ultimately we are going to get, let me erase this. Yes, so we are going to get twice a equal to, if we simplify here, this is actually 2 pi 3 pi means 5 pi, isn't it? Here 1 pi and 2 pi 3 pi, sorry, 3 pi over 6. Then the second one is going to be negative 7 positive 2, so negative 5 pi over 6. Then the third one is negative 1 positive 2, so it is actually negative pi over 6. After that, the fourth one is negative 5 positive 2, so negative 3. Negative 3 pi over 6. Then from the left side, if we transpose this 2 to the right side, what will happen? Ultimately twice alpha, this 2 will be 12. Okay, this is 12, sorry, 12 over 3 pi. Then the second one is going to be negative 5 pi, negative 5 pi over 12. That means we are just transposing these 2 to the right side. Then third one is going to be negative pi over 12. Then fourth one, last one is going to be negative 3 pi over 12. So if we simplify this, what is it going to be? It is going to be, let me erase some of the parts. We can erase this one, which is not necessary anymore for us. Well, or hence, this may be the last step, so we can use hence symbol. Hence alpha is equal to first value. We can choose the lowest one. The least one is which one? Negative pi over 12. The which one is the uh, negative pi over 12. Here there should not be a negative symbol because this is the third one. Look, third one is this. If we subtract negative 1 from 2, it will be positive 1. Okay, this should be positive, so this, there should be no negative symbol. So if we simplify, let's write the smallest one. Smallest one is this, negative 5 pi over 12, negative 5 pi over 12, and the second lowest one is negative pi over 4. Means if we divide this one, that is 3 fours are 12, and then there comes pi over 12, this one, pi over 12, and the last of all we are going to get 3 pi over 12, means pi over 4. That's all the roots we have got for alpha. I think you have understood it better than the previous two solutions. Let's move on to the next solution, so that every tiny parts, complicated parts, remains easier in your mind. Whenever you solve yourself, then you will find it very easy, because every nook and corner of the solution or of trigonometry has been explained very elaborately. Well, so the next question belongs to paper 0606/22, May June 2024, and we are going to solve question number 6. Let's see what question number 6 is. Let it be zoom out. The question says, show that sine cube x into cosec x over cot x can be written as sine square x into tan x. Well, so sine cube x, sine cube x into cosec x can be written as, this is cosec is inverse of sine, so we can write 1 over sine x, 1 over sine x and cot is cos over sine. All of you know this basic formula. Well, then sine cube x into the first upper fraction will remain unchanged, 1 over sine x, 1 over sine x into the denominator, the lower fraction will be reciprocal, so it will be sine x over cos x. Well, now then this sign can cancel out this sign, so we can write here sine cube can be written as sine square x into another sine x into another sine x, and denominator is cos x. Here we can write 1 as there is nothing, so it is going to be sine square x, and sine over cos we know it is tan x, and they have told us to show that the result is sine square x into tan x, so we have can be written if they told us to show, so we have shown, so showed. Well, the next question says solve the equation cos square x into tan x minus half tan x equal to 0, and our domain is given negative pi until pi. And look at this, this is not transformed curve, that is x, so we can easily start solving this. Well, we can write cos square x into tan x minus half tan x equal to 0. Well, if we take tan x as common factor, it is going to be tan x, then from first term there is cos square x, from the second term there remains only half equal to 0, or either tan x is equal to 0, tan x is equal to 0, or x is equal to tan inverse of 0, tan inverse of 0. Hence one of the values of x is going to be, so tan inverse of 0 is equal to 0, we know that. Or the second part, second factor, this is the another part, or let us write the next factor on the next page, cos square x minus half. So cos square x minus half is equal to 0. If 0 is transposed, then it is going to be cos square x equal to half. And whenever this is square term, so cos x is equal to positive as well as negative 1 over root over 2. And our x is going to be cos inverse of positive as well as negative 1 over root over 2. Well, or, and we know that our 1 over cos inverse of 1 over root over 2 is, let us go back to our domain. The domain was, what was the domain? Domain was from negative pi to positive pi. Well, negative pi until positive pi. That means from 120, negative 120 degree to positive, sorry, 180, negative 180 degree, sorry. negative 180 degree to positive 180 degree. Now we will draw the quadrant. Cos is for positive, we will choose the positive value. Cos is positive either in the first quadrant or fourth quadrant. So for first quadrant, it will be pi over 4. Pi over 4. Now in the fourth quadrant, let's see whether it allows us or not. In the fourth quadrant, if we move in this direction for positive value, okay, for positive value it will be more than 270, it will be around 360, which is not permitted. We can get maximum 180 degrees. So this quadrant is not applicable for us in clockwise direction. Now in anti-clockwise direction, sorry, anti-clockwise direction, we cannot get any more value. Now clockwise direction. So for clockwise direction, this is about what? For positive value, okay. Let me erase this second one. Still there is something. Now in anti-clockwise direction, we can anti-clockwise direction, this is the angle and this is the angle. So anti-clockwise direction, either it may be over here or it may be on here, okay. Let's see. For clockwise direction, it will negative value is, look, 180. Now if we can choose this one, is negative pi over 4, because this is less than 180. Then then should we accept the value in the first quadrant? Is it possible or not? Let's see. It is going to be more than 270 and less than 360. That means it exceeds our lower limit, so we cannot accept any more value. Let me erase this. This was for our positive value. Now we will talk about our negative value, okay. So cos is negative at the second quadrant and third quadrant. So clockwise direction, if we move over here, it will be more than, it will be around 180. So we can choose this. This is, so what will be it? It will be pi minus pi over 4. So it is acceptable, because our ultimate upper range of this domain is 180. So in this quadrant it may be less than 180, okay. But this is not accepted here. It will be more than 180 in the third quadrant. So we cannot take any more angle for anti-clockwise direction. Now clockwise direction, in clockwise direction it is going to be less than 180. So minus pi over, sorry, negative pi, and as we will have to do subtraction, it is going to be pi over 4. Let's see whether this quadrant is applicable or not. This is actually, look, more than, as it is moving this direction, it will be more than negative 180, which is not possible, because our lower limit will be negative 180. So this quadrant is not possible in case of clockwise direction. So how many values did we get? We got so far 4 values. We can term it as second value of x, because already we have got another value. So it is going to be pi over 4. Then second one is negative pi over 4. The third one is going to be 4 pi minus 1 pi, that means 3 pi over 4. What about the fourth one? That is 4 minus 1, so negative 3 pi over 4. Now we can arrange all of them. As this portion is not necessary, let me erase this. If I erase this, okay. Now finally we are going to write our answer. It is going to be, first of all, x1 from the x value, hence, sorry, this one should be hence, as this is the last step, we can write here x is equal to first value. You have not forgotten that we got the first value was 0. First one was, one of the values was 0, so it is going to be 0 first one. Then, oh, sorry, let me write the first one later on, because lowest value is what? Lowest value is here negative pi over 4. This is the lowest, sorry, not this, even this is the lowest of all values. So negative 3 pi over 4. Second lowest is negative pi over 4. Negative pi over 4. Then third value is our 0. Then fourth value is going to be pi over 4, and fifth value is 3 pi over 4. So ultimately we have got total 5 roots of x. So this is how we will solve the complicated problems. Let's move on to the next question. Well, the next question belongs to paper 970913, May June 2024, and we are going to solve question number 4. Let's move on to the question number 4. Question number 4 says, show that the equation cos theta into 7 tan theta minus 5 cos theta equal to 1 can be written in the form a sin square theta plus b sin theta plus c equal to 0. Well, so we are going to start the solution. So our left hand side is this, cos square theta, sorry, cos theta into 7 tan theta minus 5 cos theta equal to 1. Well, then we can multiply this cos theta, cos theta, and 7 can be written first of all. And you know tan theta means sine into cos. So we can write sine over cos theta minus, if cos theta is multiplied by 5, it is going to be 5 cos square theta equal to this. That one can be transposed to the left side, and it is going to be negative 1 equal to 0. So here cos and cos can cancel each other. This is equal symbol actually implies to. Then it is going to be, if cos is, this cos can cancel out this, so it is going to be 7 sine theta, 7 sine theta minus 5 cos square theta. You know cos square theta means 1 minus sine square theta, so it will be 5 plus 5 sine square theta. Sine square theta minus 1 is equal to 0. So 5 sine square theta, we can write 5 sine square theta. If we arrange it, 5 sine square theta plus 7 sine theta minus 1, sorry, minus 6, but minus 1, 5 minus 1 is equal to negative 6 is equal to 0. So already we have got this format. They told that a, hence our a is what? A is 5. A is equal to 5, and b is going to be 7. This one is b, and c is negative 6. C is equal to negative 6. Well, that's the answer to this part. Let's move on to the question number b. B says, hence solve the equation cos 2x into 7 tan 2x minus 5 cos 2x minus equal to 1. Remember, previously look at this. In the previous case, our angle was x, only 1 theta. That means here there was only 1 theta, okay, theta, theta. But now instead of theta, it has become what? It has become 2x. Okay, so our theta is going to be now 2x. Instead of theta, just we will write 2x. Well, so let's write the solution. Cos 2x, cos 2x into 7 tan 2x minus 5 cos 2x equal to 1. Means we can write, they have told that we can use the previous information. It has been converted to 5 sine square 2x, 5 sine square. From question number 1, from solution number 1, we are going to reuse this sine square 2x. Just instead of theta we are writing 2x, 2x plus 7 sine 2x plus 7 sine 2x minus 6 equal to 0. Then we can factorize this. 5 6 is a 30, so we can break up the middle term. 5 sine square 2x plus 10 sine 2x minus 3 sine 2x minus 6 equal to 0. Well, now we can factorize. 5 sine 2x can be taken as common. So if 5 sine 2x is taken as common, there will remain only sine 2x. Sine 2x or sine 2x. Then from this one, if 5 sine 2x goes away, there will remain only 2. Then from the next factor here, 5 sine 2x has been taken as 5 sine 2x minus, between these two terms, 3 can be taken as common, so it is going to be 3 equal to 0. Or sine 2x 5 sine 2x minus 3 equal to 0. Since, look, actually we are rejecting this. Sine 2x cannot be equal to negative 2. We may remember that the sine x, value of sine and cosine, sinusoidal and sinusoidal graphs is maximum negative 1 until positive 1. Okay, so this one is actually, the value is negative 2 is rejected, since sine 2x, because value cannot be less than, neither less than negative 1 or positive more than plus 1. Sine 2x is not sorry, is equal to negative 2, rejected. We are rejecting this, or not accepted, whatever you tell. Well, let's move on to the lower part of this solution. Already we have rejected one value, so next one is, well, so sine 2x is equal to, if 3 is transposed to the other side, it is going to be positive 3, and if 5 is taken to the right side, it will be 3 over 5. Then our 2x is equal to sine inverse of 3 over 5. Okay, then we will go back to our domain. Let's see what the domain is. X is equal to, first let it be completed. If 2 is transposed to the other side, it is going to be half of sine inverse. There is no necessity of this bracket. Sine inverse of 3 over 5. Then we'll go for the domain. Okay, let us draw the curve. Sine is positive. Look, our value is here positive, so sine is positive over here as well as there. Okay, either this is the angle or this will be the angle. Now let's see whether both of them are acceptable or not. Let us go back. our domain is this. Look at this, from 0 to 180 degree. So both the first two quadrants are acceptable. We can apply this concept. Hence, so here sine 3 over 5 using our calculator, you can use your calculator. If you just write sine inverse of 3 over 5, it will show, then you will multiply. A half can be multiplied later on, okay. It will be half of, as there are two values, half of first value is 36.87 degree, we are expressing in degree, and the second one is half into from 180. Just the whole of this is 180. From 180, if we subtract only this portion, then we will get our required value. It will be 36 minus, so 180 minus means, let me write the simplified answer. If 36.87 is subtracted, it is going to be 144 point, well, let me write this, 180 minus how much, 36.87 degree. So ultimately what will we get? We will get x is equal to, this is 18 point how much, 18.4 degree, and the other one is, let me write this comma, other one is going to be 18.4 degree, and this is okay, half into 180 minus 36, that is 71.6, 71.6 degree. So that is our solution. Now one more question may arise in your mind: why didn't we define the domain here? So let us define here. The domain is 0 to 180 degree, okay, and our the curve was transformed curve. Let me move on to it was 0 to our, look at this, our domain is 0 to 180 degree, okay. So let's go to a new page, 0 degree to 0 to 180 degree, okay, 180 degree. Well, so it has, the curve was actually enlarged with the scale factor 2. So if we multiply 0 by 2, it is 0, this is twice x, then this is going to be 360. That means here there is no negative value as all, at all. That means we cannot move clockwise direction. Well, so we can only move anti-clockwise direction, and we have decided the sign positive is over here as well as here, angle was here as well as here. Now let's see, as there is no scope of moving clockwise direction, we will just move on anti-clockwise direction. That means the values lie either in the first quadrant and in the second quadrant. That's why we have got only the values of this quadrant as well as this quadrant. These two are not acceptable in this case at all. So if you simplify the domain, again you will get the same result. Thank you all. I think you have understood so long. I have tried my level best to make you understand. If the video benefits you for learning any tiny part of trigonometry, please pray to the Almighty God for, so that He blesses me more and more. Thank you.